Yeah.
So we're working on exponential growth and decay.
Okay.
So number one is t is equal to 5 for all of these. So it's for one, y is equal to 350, and then in parentheses 1 plus 0.75 to the power of t.
1 plus 0 point what?
0.75.
Like that?
To the power of t, yeah.
Okay. This is annual compounding. In other words, if you were to go to a bank and deposit $350 in it, and they were paying you 75% per year, this is what it would be worth after T years. So what's the question here?
Well, we have to identify the initial amount A and the rate of growth R. A is equal to 350 and R is equal to 1 plus 0.75.
Yes. Okay. What else? That's it?
And then we have to find when
Have to solve it at all with T equal to anything?
Yeah. T equals 5.
Okay. So, do you have a calculator?
Yeah, let me just get it out.
Get it and come up with that number right there.
So you want 1.75 to the power of 5?
You have to do that first, and then multiply the whole thing by 350.
Yeah, no. Um, 5,744.
Yeah, that's pretty good growth, huh? In other words, if you actually could earn 75% per year on your money, you could turn $350 into $5,744 in 5 years.
That's a lot.
That's really a lot. That's a huge rate of growth. What else you got?
Y equals 25 times 1.2 to the 10th to the 5th.
Okay. What's the starting amount?
Well, for one thing, T is equal to 5 for this one, too.
Yeah.
A equals 25 and R equals 1.2.
R actually is not equal to 1.2. R is actually equal to 0.2. In other words, the real formula is this.
1 plus. Yeah.
Okay, so R has to be 0.2, meaning your rate of growth is 20% per whatever time frame T is in.
We had to actually learn this in class 3-way series of notes that our teacher wrote down because she wasn't here. So,
so come up with this number.
Okay.
Could be in the neighborhood of 50.
62.
Yeah. And notice the difference between getting a 20% rate of return versus getting a 75% rate of return. 75% grows by almost a factor of 20, whereas when your R is just 0.2, it barely doubles it. Okay, what else you got?
Y is equal to 1,500 times 1.074 to the power of 5.
1.074?
Yeah.
So A is what? A sub 0 is what?
A is equal to 1,500.
And R is what?
0.074.
I don't ever write that leading zero. I don't know why anybody does. Has anybody ever given you a good reason why you write it?
Actually, no. I don't really like when people do that either.
I don't write it. To me, it's absolutely unnecessary. The decimal point tells you everything you need to know. So putting an extra zero in there is just writing extra stuff that you don't need. Now, maybe if your teacher tells you that you absolutely have to put that leading zero, go ahead and do it. But I've never heard any math teacher say that. So I would write it like that. In other words, when you add zeros, it just kind of makes it more complicated. Especially when you add a completely unnecessary zero like that one. Some zeros are necessary, but if I told you 0.7 and I want to add zeros there, those aren't necessary either, are they?
Nope.
So I don't write zeros where they're not necessary. All right, and then when you figure out this number, what do you get? This should be in the neighborhood of like 2,500.
Okay, then I guess it would be like 2145.
Yeah. In other words, this is a 7.4 percentage rate, as opposed to the last two, which were 75% and 20%. Well, that's a lot less. So when I take that to the fifth power, it isn't even going to double. And then when I multiply it by 1,500, it barely gets me up to 2145. So what these three problems kind of tell you is, wow, what is the power if you can earn a higher rate of return? Makes a tremendous difference. Okay, what else?
Y equals 6.72 times 2 to the power of 5.
What's A?
6.72.
What's R?
That would be 1.
Good. And what's that?
The answer,
It'd be 32 times 6.
215.
I was going to say neighborhood of 200. Okay, what else?
We have to write a function that represents the situation.
Okay.
Sales of a $10,000 increase by 65% each year.
Nice. I'd like to have that company.
So the function is y equals 10,000 times 1.65 to the power of 5.
All right.
I don't know what to put for t.
What's R?
I don't know what to put for t, so I just put 5.
Well, you told me at the very beginning, this is always t. And you told me that he just wants you to evaluate it using a t of 5. Now,
Well, I mean, then the part after this, it's for a t of 3.
Oh, okay. Notice that t does not have to be in days or years or weeks. It can be anything. But this 65% growth rate is in whatever t is in. In other words, if t is in days, like for bacteria, if you had bacteria in a petri dish, then t would be measured in days. And every single day, the bacteria is growing by 65%. So the units that go with t can be variable. Sometimes t can be in seconds, sometimes it can be in hours, sometimes days, sometimes weeks, sometimes years. But whatever unit it's in goes with R. In other words, this is not, if this was a yearly figure, then T would have to be in years. But with bacteria, you could have bacteria grow by 65% every day. So this might fit bacterial growth. There's certainly no bank account or any kind of investment that I can think of that would grow by 65% per day. There's not many that would grow by 65% per year. But you might find some that grow by 65% per year, very high risk investment. So when you substitute 5, what do you get? Do this first.
Y equals 12228.
Which is 122,000. So that's pretty good. You've multiplied your 10,000 by a factor of 10, more than a factor of 10, by earning 65% per year for 5 years. Again, it shows you if you can get a really high rate of return, you can really grow money fast. All right, what else?
Y equals, or starting annual salary of $35,000 increases by 4% every year.
So what's the equation that applies?
Y equals 35,000 times 1.04 to the fifth, if we're still using 5.
And this was T was 5, not 3?
Yeah, but like starting at after like.
All right. So what's that number?
The answer would be Y equals 42,582.
Yeah, and that makes sense. In other words, 4% is not a huge growth rate. So you're going to turn 35,000 into 42,000, but that's not much after 5 years. But that's because 4% is not much of a return, even though it's actually a good return these days. But there was a point in time where 4% would have been considered measly. Now it's actually a pretty good return. If you were sitting on $1 million and wanted to invest it, you'd be really lucky to be able to make 4% per year. Okay, what's the next one?
A population of 210,000 increases by 12.5% each year.
How much? 200 and what?
210,000.
210,000 increases by 12% per year. The equation that applies?
Y equals 210,000 times 1.125 to the power of 5.
1.12, right?
But it increases by 12.5%.
Oh, 12.5. Okay. I need to add a 5 to that. Was this for t equal 5 or t equal 3?
Yeah, t equal 5. I'll tell you when we get to t equal 3.
All right. What's this number?
That would be
That's a pretty good rate. That should at least double. Come close, I would think, to doubling your basic money.
that would be around 378,426.
Kind of helps to have a broad idea of what it's going to be because that's in the ballpark. When I said double, wasn't quite, but it's not 20 times and it's not less than 210. So you know it's going to increase. All right, what else you got?
An item costs $4.50 and its price increases by 3.5% each year.
What's the increase? 3.5%? This 5 years or 3 year?
For each year, 5 years.
So the equation is what?
Y equals 4.50 times
Is it 50 or 15?
50.
Okay.
Y equals 4.50 times 1.035 to the power of 5.
Again, I don't feel a need to put a 0 after that 5. The same number, 4.5 or 4.50. Why put in zeros that just make things bigger? Okay, what's this going to be? That's not much of an increase. I would expect it to increase it to about 7.
That would be $5 point
Really?
344.
5.344?
Yeah.
Okay. That shows you that 3.5% doesn't grow very fast. Even after 5 years, it doesn't grow very fast.
Nope.
We barely increased this by less than 20% total. Okay, what else?
A young channel catfish weighs about 0.1 pounds. During the next 8 weeks, its weight increases by about 23% each week. Right next exponential function, that represents the weight of the catfish after t weeks during the 8-week period.
Now, notice that the rate of change was per week. That means t is going to be in weeks.
Yeah, so t would be 8.
Okay, so what's the full equation?
Y equals 0.1 times 1.23 times 8 to the power of 8.
This was, what is his weight going to be at the end of 8 weeks?
Yeah.
Okay. Go ahead and do the math. It's a pretty good growth rate. This fish is going to grow pretty good.
It would equal to y equals 0.524 pounds.
Notice that it increased by a factor of 5.5.
Yeah.
That's what 23% over 8, 23% increases it by a factor of 5.5. Okay, what else? Seem to have these down pretty good.
Yeah, well, I didn't have it today when we were doing the lesson. Because she only gave us her notes, so we kind of had to guess on some things. So it's identify the initial amount a and the rates of decay r as a percent the exponential function. Evaluate the function t equals 3. Round your answer to the nearest 10th.
All right, I didn't really understand everything you just said. It's a decay function, which means 1 minus r instead of 1 plus r.
Yeah, and it's t equals 3. Now,
What's everything else? What's the starting amount and the rate of decay?
rate of decay, so it probably means like 1 minus 0.6 or 1 minus whatever that number is.
So r is what? 0.36? I'm not understanding your numbers that you're...
Okay, so, no, I haven't started the problem yet. Y equals 575 times 1 minus 0.6 to the power of 3. Equals 3. A would equal 575 and R would equal 60%.
Okay, what's this number?
That would be 36.8.
Notice, in 3 years, you're losing 60%. So after 1 year, you're going to have about 200. After 2 years, you're going to have about 120. And after 3 years, okay, you sure that's the right answer? It seems off a little bit.
Let me try again.
You do 0.4 to the third power?
Yeah, that would be... Oh, I did something. That would be 0.064.
0.064? No, that's not going to be right either. Oh, that's what that to the third power is?
Yeah.
Okay, now multiply that number by 575.
36.8.
All right. Interesting. So if you lose 60%, in other words, if you had a piece of plutonium that lost 60% of its mass every year, it would go from 575 grams down to 36.8 grams in 3 years. So when something loses that much per year, that's a lot. It really loses quite a bit. Okay, what else?
Y equals 240 times 0.75 to the power of 3.
What's R?
R is equal to 75%.
No. Remember that when you're dealing with decay, what's in the parentheses is always 1 minus R.
Uh-huh.
So what's R got to be?
Oh, it would be 1.75.
Be 0.25. R is equal to 0.25 because then 1 minus 0.25 would be equal to the 0.75 that you gave me.
Oh, yeah. Sorry.
Okay? All right, I'm glad we got the one that you didn't know. You've known them all so far. So R is 0.25. Doesn't really matter with, to come up with an answer for what Y is after 3 years. What is Y going to be? Going to be about 100, a little less.
101.
101?
Yeah.
Okay. What else?
Y equals 700 times 0.995.
700 times 0.995. What's R here?
Would that be 0.005?
Yeah. And is this 3 years?
Yeah, it's still 3 years.
What's that Y going to be?
I don't think I got this one, but 689.
689? That actually makes sense. In other words, R is really, really tiny.
Oh, yeah.
R is 0.5%. So we're not losing much every year. We're losing very, very small. Notice that 1% of 700 is 7. So 0.5%, the first year we're only going to lose 3.5. Second year, a little bit less. Third year, a little bit less. Total loss would be 11. All right. Logan, I am going to let you go.
Okay.
And I will, you're all on top of this for sure. I will talk to you next time.
Okay, bye.